Okay, so we're working on answering the question, how do I know where to round to? Well, before we can truly answer that question, there's a few skills that you need to have first. So the first thing you need to be able to do is you need to be able to look at a measurement and identify which digits in that measurement are significant and which digits are not. Now remember, in a measurement, a digit is significant if it is the digit that is certain or the first guessed digit. So let's say, for example, I was reading this graduated cylinder. We would look at that and say, okay, well, 36.5 milliliters. The 3 and the 6 we're sure of. The 5 we're guessing at. So those two are certain. The 5 is a guessed digit, but all of those digits are significant because I either know what they are for sure or have a really good idea of what they are. So this particular measurement here has got 3 digits. All are significant, so it has what we call 3 sigfigs. Now, some cases, identifying the number of sigfigs is very, very easy. If the number does not have any zeros in it, then life is easy because all non-zero digits are significant. So if my balance said this, 65.346 grams, there's 6 digits in that reading. All of them are significant. 5 digits, so that means that measurement there has 5 sigfigs. Zeros are the troublemakers, and the reason why is because sometimes a zero is a part of the measurement where we're saying, yes, this digit here, this measurement is a zero. But other times, zeros are simply placeholders. For example, let's pretend that we were looking at Beaver Stadium here at Penn State. Now, we know that there's 106,572 seats. So we might want to estimate, okay, how many people are at this game in this picture? And we can look at it and see, well, I know there's 106,572 seats, and man, it looks like those are all pretty filled. I don't see very many empty seats. So we might come up with a reasonable answer that I think there's 105,000 people in this stadium in this picture, and that's a pretty reasonable answer. Now, in that answer there, we can be pretty sure about the 1 there. It's definitely very close to full. We know it's not 90,000. It certainly can't be 110,000. So we're certain of both the 1 and the 0, and we're saying, well, it's awful darn close to full, so we're guessing at that 5. It certainly could be 104,000. It might even be 106,000. It might be 103, 104. We're guessing at the digit. We have a pretty good idea what it is, though. Now, in this case, we have the 3 zeros on the right side. We have no idea what digit should go there, so those are not significant zero. Those are merely placeholding zeros. They're there to keep the number that big. We're talking about 100-some thousand, so I have to have those zeros so that it's still 100-some thousand. So in that particular estimate, that measurement there, we really only have 3 sigfigs. Again, that's a good example because the 3 zeros on the end are not significant zeros, but that 0 in the middle is. It is a part of the measurement. So with zeros, sometimes it's pretty easy. Whenever you have a 0 that is sandwiched between any 2 non-zero digits, those zeros are always going to be significant. For example, in this case, the zeros are sandwiched, they are significant, so we've got 4 sigfigs there. In the next case, now only some of those zeros are sandwiched, so only those zeros between the 8 and the 4 are significant. The 3 zeros at the end are not, they're just placeholding zeros, so that measurement only has 4 sigfigs. This one here, now you've got a couple, but they are sandwiched between the 6 and the 3. So those 2 zeros surrounding the 5, those are significant. The 2 zeros on the end are not, so that digit has 5 sigfigs. Now, a quick and easy way to tell if a 0 is going to be significant, if you're not sure, is this just a placeholding 0 or not, is to use what's called the Atlantic-Pacific rule. This can help you determine not only if a 0 is significant or not, but how many total sigfigs the number has. So step number 1 is to imagine the number superimposed over the United States, and then ask yourself, does the number have a decimal? Now, before you ask yourself that question, you need to know a little geography to use the Atlantic-Pacific rule. So you need to know which side of the U.S. the Atlantic Ocean and which side the Pacific Ocean. There's a little help for you just to visualize again. Now, once you've done that, you need to ask yourself, does my measurement have a decimal in it or not? Now, of course, there's going to be one of 2 answers. If the answer is yes, and if a decimal is present, then you're going to start from the Pacific side of the number. So imagine you're on the Pacific Ocean and you're cruising through the United States. You're cruising across that number. Well, you're going to cruise through all the zeros and you're going to keep going until you hit a non-zero digit. In this case, I hit the 4. When you hit a non-zero digit, that is going to stop you. Now, all the zeros that you cruised through until you were stopped, those are not significant zeros. Those are just placeholding zeros. In this case, they're just there to keep the number that small. Now, from the point you were stopped and for the rest of the digits over, those are significant digits. So all those digits at the end there are significant. So this particular number that we had in this example, we had 5 sigfigs. Decimal was present. Came from the Pacific side, the 4 stopped us. Everything from that point over is significant. Let's look at another example. Now here I look at my number here over the United States, and I ask myself the question, is a decimal present? In this case, the answer is no. A decimal is absent. So this time, we're going to do the same thing, but we're going to start from the Atlantic side. Again, we're going to cruise through our number until we get stopped by a non-zero digit. In this case, the 3 stops me. So just like before, the zeros that we cruise through, those are not significant. They're just simply placeholding zeros. So from the 3 on, all the rest of those numbers are significant. So that number there had 3 sigfigs.